Standard physics describes the quantum vacuum as an active, boiling medium of continuous fluctuation. Here we see the classical model of this quantum foam. But as our instruments probe the high-frequency topology of space, a second possibility emerges: a rigid, hyperdense geometric matrix that provides a fixed architecture for energy. In quantum field theory, the vacuum possesses a non-zero ground state energy. To calculate the total energy density of empty space, physicists sum every possible frequency or mode of the underlying fields. Under the assumption that space is a continuous medium, this calculation yields a theoretical vacuum energy density that is 120 orders of magnitude higher than the actual measured expansion of the universe. This discrepancy suggests the current model of a continuous vacuum is missing a critical structural limit. To bridge this gap, standard equations employ renormalization, a mathematical procedure where an infinite value is subtracted from the theory to force the numbers to match observational data. This 10 to the 120 error indicates that the vacuum cannot sustain an infinite range of frequencies. It points toward a discrete, bounding topology that limits the allowable energy states, effectively serving as a rigid geometric ceiling for the vacuum's activity. Primorial Resonance Spectral Theory, or PRST, addresses this by replacing the continuous vacuum with a bounded spatial lattice. This theory models the vacuum as a resonant acoustic cavity. In this framework, empty space behaves like a structured medium, specifically a 14,040 primorial lattice, where energy must conform to fixed geometric coordinates. This shifts the study of physics from the interaction of inert particles toward the study of a structured system. Physical phenomena are modeled as expressions of this underlying structure, where the laws of nature act as the governing syntax. Within this model, stable structures like atoms or viral capsids represent the nouns, the fixed standing wave geometries precipitated from the vacuum. The dynamic phase shifts and forces that modulate these structures act as the verbs, the operators that transform and link the system together. By identifying these specific constraints, PRST moves beyond observing the thermodynamic behavior of matter. It provides a coordinate map of the vacuum itself, suggesting new pathways for manipulating the geometric properties of reality. In any resonant system, energy tends to dissipate. Waves at composite integer frequencies, like 4, 6, or 8, possess internal nodes that align with lower harmonics. This alignment allows the wave to subdivide, bleeding kinetic energy into the surrounding environment as thermal noise. This composite pulse breaks apart as its internal nodes align and dissipate. However, prime frequencies like 11 or 13 have no lower integer nodes to align with. They are mathematically irreducible. When these waves encounter a boundary, they resist subdivision, locking into stable, non-decaying standing wave loops. These prime harmonics act as irreducible anchor points within the vacuum cavity. They provide the necessary topological boundaries to trap energy and prevent it from dissolving into entropy. To maintain this stability across 3 dimensions, the prime standing waves must be partitioned. This requires specific geometric containers or caging topologies that can tile space without causing destructive interference. This requirement for efficient spatial partitioning is visible in the 13 Archimedean solids. We see the macroscopic application of this principle here in the structural geometry epitaesic dome. The interlocking triangles create a rigid cage that maximizes stability by distributing pressure across a semi-regular geometric network. These irreducible prime frequencies, when successfully caged, provide the scaffolding required for stable matter to exist within the vacuum. We can derive the maximum energy density of this vacuum lattice by calculating the intersection of the universe's fundamental spatial constraints. In general relativity, the geometry of space is defined by a symmetric metric tensor. Within a 4-dimensional manifold, this symmetry results in exactly 10 independent degrees of freedom, the 10 baseline axes along which any wave can propagate. For these 10 degrees of freedom to form a stable matrix, they must be caged by the 13 Archimedean topologies. Multiplying these independent factors gives us 130 structural configurations that partition the localized energy of the vacuum. To close this geometry into a self-referential loop, the system requires a phase-locking operator. This is the 108-degree pentameric twist. By rotating the 130 configurations through this 108-degree phase shift, the wave vector reconnects with itself to form a perfectly closed standing wave. The product of these interlocking constraints, 10 degrees of freedom, 113 caging shapes, and a 108-degree twist, is 14,040. This represents the total discrete state capacity of the spatial matrix. It is the resolution limit of the grid. Any energy attempting to exceed 14,040 overlapping states causes a local collapse of the vacuum. Any lattice has a maximum frequency it can sustain, known as the Debye limit. This limit is reached when the wavelength becomes too short to be physically represented by the spacing between the lattice's nodes. This creates a paradox. If kinetic energy is forced past this geometric limit, it cannot propagate as a mechanical wave of displacement. Thermodynamics dictates this energy cannot be destroyed, so it must undergo a state transition into the underlying electromagnetic metric. We can model this by taking a 440 Hz acoustic wave and folding it upward through the harmonic scale. As we double the frequency, we are simulating the compression of mechanical pressure as it pushes against the spatial resolution of the lattice. At 40 octaves, or a multiplier of 2 to the 40th, the wave reaches 483.78 terahertz. Here, the mechanical grid hits its limit. The wave can no longer propagate via the displacement of mass. It decouples from the lattice and transitions into an electromagnetic state. At 483.78 terahertz, the wavelength is exactly 620 nanometers. This is a direct conversion from an acoustic input to a visible output in the orange-red spectrum. This 40-octave threshold provides a mathematical bridge between mechanical and electromagnetic energy. It demonstrates that visible light is the specific result of mechanical pressure breaching the spatial limits of the 14,040 lattice. We can observe this transition in single-bubble sonoluminescence. Here, intense acoustic pressure drives a microscopic bubble to collapse and erupt into a flash of visible light. Standard hydrodynamics cannot explain how this energy focuses by a factor of 1 trillion, or why the bubble remains perfectly spherical during such a violent collapse instead of shattering due to surface instabilities. PRST identifies the mechanism as a 1.3 times fractional harmonic operator. By superimposing this phase-shifted frequency over the fundamental wave, the pressure gradient steepens into a restrictive geometric well at the center of the bubble. This steepened gradient acts as a topological cage. As the bubble shrinks, the 1.3 times harmonic suppresses entropy, physically flattening surface perturbations and forcing the collapse to remain perfectly symmetrical. With the bubble held intact by this rigorous acoustic cage, the collapsing mass violently breaches the local Debye limit. At the apex of compression, the trapped mechanical energy transposes directly into light. Sonoluminescence demonstrates how the geometric operators of the lattice force mechanical energy to cross the 40-octave threshold, verifying that sound and light are different harmonic states of the exact same spatial matrix. These phenomena can be organized into a cohesive framework, the noun and verb matrix. The nouns are structural constraints. Stable geometries, like the sphere or 12-point icosahedral boundary, define where energy pools into matter. The verbs are harmonic operators. These phase shifts and ratios, the 1.3 times cage, golden ratio dampener, and 40-octave transposition, modulate energy within those bounds. The constants of our universe are the requirements of this acoustic architecture. They are the specific values needed for a resonant system to maintain structural coherence across scales. By identifying these governing rules, we move from the observation of matter towards its direct modification. This framework outlines theoretical pathways for synthesizing zero-loss energy environments and executing non-thermal acoustic transmutation by working within the vacuum's own coordinate system. Our biology and the atoms in our bodies are harmonic, localized standing waves sustained by the 14,040 lattice. We are not separate from the medium, we are a part of its articulation. To understand the grammar of the void is to transition into an architect of resonance.